Hello everyone. Okay, in class today you asked me to work out a problem of bond prices using the present value and future value equation, and I'm about to do that on the whiteboard behind me. But you should know that the equation has three variables: the present value, the future value, and the interest rate, and I could give you any two of those and you should be able to find the third. So I've created a couple of examples that would be typical for issues at the Federal Reserve. But remember, if I give you any two, you should be able to find the third by using that basic formula. Okay, so let's try to see if we can do this. So imagine that you had a government bond, and let's say the bond is worth $500,000 when it matures, and maybe it matures in 10 years. And its current selling price is $400,000, and so the question would be, well, what is the effective interest rate? And the way you do that is it's the future value of something is equal to its present value times 1 plus the growth rate raised to the number of years out. And so in this case, the future value is $500,000. The present value is $400,000. The growth rate's the thing we don't know, and we know it's 10 years out. So we just divide both sides by 400,000. I think that's 1.25 equals 1 plus the growth rate raised the number of years out. Okay, so now I have to take the 10th root of both sides to get rid of that 10 right there. So take the 10th root of both sides. I get 1.02256 equals 1 plus the growth rate. And then if I subtract 1 from both sides and multiply by 100 to get into percent, I get the growth rate is 2.256%. So to answer the question, if a bond that matures in 10 years whose face value is $500,000, if that bond were to sell in the open market today for $400,000, that means the effective interest rate is 2.256%. Now, imagine that Ben Bernanke or whoever is the head of the Fed decides that they would like the interest rate to be higher than that. Maybe they would like the interest rate to be, say, 3%. So would Ben need to buy or sell bonds? Well, the first thing to realize is to get this number up to 3%, we need the interest rate to go up, which means, of course, the bond price must go down. The bond price must go down. So Ben would sell bonds. He would sell them, and he would drive the price down to what? That is, the question now is, how low must the price of the bond go so that the effective interest rate is 3%? Again, the solution is the same as before. It's the future value equals the present value times 1 plus the growth rate raised to the number of years out. The future value is 500,000. The present value is the thing we don't know this time, but we want the growth rate to be 3%, and we know it's 10 years out. So this one actually is a little bit easier. 1.03 raised to the 10th power gives me a value of 1.3439 times the present value must equal 500,000. So I'm going to divide both sides by that 1.3439. And I get the present value needs to drop to $372,046.96. $372.46.96. So if I put the question on the test, what would Ben need to do to get the interest rate up to 3%? He would need to sell bonds, and he would need to sell a sufficiently large number to drive the price of this typical bond down to $372.046. On the other hand, what if the head of the Fed didn't want interest rates to go up, but maybe they wanted them to go down? So let's go back to the original problem where the interest rate was 2.256. What if the Fed wanted the interest rate to fall to 2%? It'd be the very same kind of problem. I'm not going to rewrite the equation, but it would now be 500,000 equals the present value, and again we don't know what that is, times 1 plus the growth rate, and in this case we want it to be 2%, so that'd be 1.02 raised to the 10th power. So it's the very same problem again, it's just we're using a 2% interest rate. So 1.02 raised to the 10th power gives me 1.21899. Divide both sides of the equation by that number, and I get $410,174 would have to be the present value. So in this case now, to go back to the original, if Ben wanted the interest rate to fall down to 2%, he would need to drive bond prices up, and the bond price would have to go up to $410,174. So that's how you work these. But you've seen these before. We did these back when we were studying the inflation rate. It's the same formula. It's just now we're buying and selling bonds. So I hope you found this helpful. Good luck.